Now that I've defined a general operation, I want to look at properties of these operations. And different operations are going to have different properties. So let's start by considering a couple of very basic properties. My first property that I want to look at is commutativity. A star B equal to B star A. I can switch the order of my operation. Addition on the real numbers is commutative. We know that A plus B is equal to B plus A. Multiplication on the real numbers is commutative. We know that A times B is equal to B times A. However, multiplication on 2 by 2 matrices is not commutative. Here I'm going to multiply these two matrices and I get 1, 1, 1, 2. However, if I switch the order, I get 2, 1, 1, 1, which is not the same thing. So not all operations are commutative, but they can be. The next property I want to consider is associativity, that I can change the order of parentheses. We know that addition on R is associative. A plus B plus C is equal to A plus B plus C. We can move the parentheses around in addition. In addition, we know that multiplication on the real numbers is associative. A times BC is equal to AB times C. However, division on the positive reals is not associative. If we have 3 divided by 4 over 5, that gives me 15 over 4. However, if I do the division 3 divided by 4 first and do 3/4 divided by 5, I get 3 over 20, which is not the same thing. So not all operations are associative. They can be, but not everything will be. The next property I want to look at is the idea of an identity. The identity tells me that E star A should be the same as A star E, which is A, for every element little a in my set. So essentially it's something that whenever I perform my operation, I get the same thing. So as an example, if I want to consider addition, my identity would be 0, since 0 plus any number is just that number. In the case of multiplication, my identity would be 1, since 1 times any number is just that number. And so not every operation is going to have an identity, but some of them will. Let's let A be a set and star be some operation on this set. If star has an identity, then it will be unique. So identities don't have to exist, but if they do, they are unique. So let's actually prove this. Let's suppose I have two identities, E1 and E2. Then I have that E1 star E2 is equal to E1, since E2 is an identity. So the definition of an identity would mean if I take something and star it with E2, I get the other thing. Similarly, I can say that E1 star E2 is going to be equal to E2, since E1 is an identity and starring with the identity should give me what I put in. So this gives me that E1 must be equal to E2 since the output of an operation is unique. So I only have one identity. I started with 2 and showed that in fact they were the same thing. So if an identity exists, it is unique. The next property I want to look at is the idea of an inverse. For this, we would want A star X to be equal to X star A to be equal to my identity for any element A in my set. So the idea is now I have something that I can star with A to get back to my identity. So in order to have an inverse, I need to have an identity. And we say that X is the inverse of A. As for some examples, if I want to consider addition, my inverse is negative A, since I know that A plus negative A is 0, which was my identity for addition. If I want to consider multiplication, it would be 1 over A, since A times 1 over A is equal to 1, which was my identity for multiplication. However, it is important with multiplication to specifically point out that a is not equal to 0. So it is possible that we have inverses for some elements, but not others. And most of the time, we denote the inverse by a to the negative 1. So a to the negative 1 is going to mean inverse. So we could write this as a star, a to the negative 1 equal to e.